Good evening to everybody. Appreciate you taking out time to listen in on today's session. My name is Kapil Shardha, and I am AWS Solutions Architect based out of New York City. I mostly work with enterprise customers to help them design their AWS serverless strategy and absolutely with their adoption as well. So in the next 15-20 minutes, I'm going to go over what it really means to run serverless workloads on AWS. So without further ado, let's get started. So let's start with understanding the evolution. On the compute side, we have seen a paradigm shift. Many companies, even today, like to maintain their own data centers, and there are a variety of reasons for that. But by doing that, they are not really able to leverage all the innovation that's happening in the cloud. Think of making a new service or a new application, which means building a new team to build, operate, and maintain that new application. You need to renew the hardware regularly to keep up with the pace. And then, of course, you have an upfront capital expenditure before you can do any innovation. Then there's a good set of customers that are moving to the cloud and leveraging virtual machines. Of course, there have to be certain reasons why you want to move to the cloud, and I'll quickly go over a few of them. I know my colleagues have covered them early in the day. The first that is top of the list is essentially the agility that comes with the cloud, where you can spin up and down resources as quickly as possible and easily. AWS Cloud provides a breadth of functionality. We have over 175 services. And by that, the innovation that AWS does on behalf of our customers makes it possible for you to just focus on your business case. The third one that goes with the advantages is essentially the cost model. You pay for what you just use, and be able to make your applications available across the world by deploying to multiple regions and spreading across AZs. Finally is the elasticity, which removes the heavy lifting required in resource planning beforehand. Of those, well, cost is typically the decision and the discussion starter, but we believe agility and innovation are at the top. You can set up infrastructure for an experiment fearlessly and terminate it if it does not work out. And that increases the amount of innovation that happens in your company. Third is a wave of containers, which gives you a high degree of mobility. You are running something on-prem and want to keep those investments, yet to be able to run in production in the cloud. Containers allows to package your application and move them between different computing environments, including between on-prem and AWS cloud. Starts a lot more rapidly than the VMs, and you get this fancy tool chain. But you're still managing servers under the hood, updating the operating system, and patching it for the most part. And then there is serverless, where you don't have to worry about any of that. Customers tell us containers are great, but managing the infrastructure is the undifferentiated heavy lifting for them. Too much of the time is spent corralling infrastructure, not enough time is spent on the code, the application, and the application architecture, which is really where they want to focus. This is exactly what is offered by AWS Serverless. You build code and let somebody else worry about the infrastructure. So let's understand what is AWS Serverless, and you'll find a variety of definitions for serverless online. We define serverless as a way to describe the services, practices, and strategies that enable you to build more agile applications so you can innovate and respond to changes faster. With serverless computing, infrastructure management tasks like capacity provisioning and patching are handled by AWS, so you can focus on only writing your code that serves your customer. Serverless services like AWS Lambda come with automatic scaling, built-in high availability, and a pay-for-value billing model. Lambda is an event-driven compute service which enables you to run code in response to events from over 150 natively integrated AWS and SaaS sources, all without managing any servers. And we'll look at AWS Lambda in a bit more depth in the next couple of slides. So let's talk about what a serverless business strategy really means for your business. A serverless strategy enables you to achieve the maximum value from the cloud. And by serverless, we're talking about applications that are built with technologies that eliminate the need to manage servers, scale nearly infinite automatically, user pay for what you value pricing model, and are automatically highly available. Now, this strategy, often referred to as serverless operational model, enables you to dramatically reduce the time spent on things that aren't core to your business, like managing servers, and focus on the products that drive your business. Many customers have made a decision to achieve this value through a quote-unquote serverless first strategy, or a decision to use serverless services as a preference, unless the use case or the workload demands they choose otherwise. Many customers like iRobot, Alma Media, and Fender are all serverless first customers. One of the big reasons for the growth of this approach is the new role of applications themselves. Over the past 20 years, the role that the application plays has dramatically changed from a supporting utility to the business itself. So with this in mind, a serverless first approach enables customers achieve the maximum benefit from the cloud, which is faster time to market and maximum agility. There are many paths of modernization, as there are organizations. However, we have seen this pattern emerge most commonly. We refer to this as the organic adoption pattern because it is grassroots and tends to occur without any outside influence. So basically, it starts with the developers who discovered that Lambda function can help them automate basic ID processes. They just use it for small projects like cron jobs, project they can start and complete without detailed scrutiny. Then they start wondering what else they can apply this principle to. And data transformation is one of the next common projects. This is high profile. And so we start seeing the involvement of directors and the senior leadership. And eventually, executives start to notice that projects are being delivered faster and under budget. And then they start wondering if they can apply this in other areas. Should we use serverless microservices everywhere? So at this point, the CTO organization has all of a sudden taken note, and we are talking about how to apply serverless model across the organization. Let's look at some of the patterns that we have seen, how customers are adopting serverless. A lot of customers are in the lower left corner where they have monolithic applications and they're deploying on-prem. So the first step is they do lift and shift to the cloud, such as EC2. And then they get cost-saving benefits. For example, many of our AWS customers have moved their workloads from on-prem to cloud and are already seeing over 60% savings in the cost. And then they use one of the managed container services to bring agility and closer to their nirvana state. Or maybe they choose to containerize first and then they move to the cloud. In either case, customers are getting closer to the vision of not having to manage infrastructure. Then there are some customers that are skipping all of that. For example, this was Fannie Mae's adoption pattern. This is not common and not the most common, but these are traditional enterprise IT that are architecting straight for serverless applications. Another pattern is incremental refactoring. So this is essentially the Amazon.com story. This is also known as what we call is strangler pattern. The metaphor is that you are chipping away at your monolithic application by setting up APIs and breaking up the application until your tree or the monolith is gone away, and you have just got a serverless microservices application. Now we have talked about containers, ECS. You've seen Fargate on the slide, and Lambda a bit. So the serverless operations model first initially looks like this. Number one, you can start at the very bottom with EC2 and have access to all the knobs you want to manage, or you could go completely serverless with Lambda and Fargate, where you will be focusing just on your application. Number two, so the layers of abstractions available to you with AWS is super empowering because your teams have the choice to pick the layer of abstraction they're most comfortable with. And we'll provide you the tools, services, and the APIs necessary to help you build your application. A lot of our customers want to get a spreadsheet and do a side-by-side comparison of what it will cost to run their application in EC2 and Lambda before they ever write any code for Lambda. And then they conclude that Lambda is way too expensive. But the truth is that the role of operations has changed and has been changing pretty much with Lambda and serverless services, that we need to really think about what this looks like in practice. It is difficult to estimate the cost of Lambda before running a POC because you're running infrastructure as code. So for example, if you have two development teams working on two different applications and they're both using AWS Lambda, you'll have two different builds. Now, you can evaluate how elegant and efficient their code is by just looking at the bill, but you're paying for the CPU that you use with Lambda. So there is a direct relationship between those two things. Now, this means you're thinking about TCO, the total cost of ownership in the development phases. So no more free servers for developers when they design for efficiency. You'll reap the rewards with your bill. Now we've talked about AWS Serverless from the business perspective so far. So let's get into a bit more technical details next couple of slides. So I want to start with AWS Lambda. As mentioned earlier, AWS Lambda lets you run code without provisioning or managing servers. With Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. You can set up your code to automatically trigger from other AWS services or call it directly from any web or mobile app. So the model of compute is simple. You have an event coming from an AWS service or an invocation, which is a request coming from an endpoint or a change on a resource, and your code gets executed. This code can be built with virtually any kind of language. Out of the box, we support and manage the ones that are on the slide, starting with Node.js, Python, Java, C#, Go, PowerShell, and Ruby. But you can bring your own custom runtimes as well. From this code, do what your business need. Connect to services, public endpoints, calculations, databases, transformation, basically just code. One thing to keep in mind, and many of you may already know if you're using Lambda, that today the execution time for any Lambda function is limited to 15 minutes. And essentially, this is an example of an event-driven architecture. Now, let's look further more into what a Lambda function is comprised of. So think of Lambda function having three parts. The first is event object, which is the event which triggers this code, and it has its context gives you information about the actual execution of the Lambda. The second is the function itself. So it's a resource that you can invoke to run your Lambda code. A function has the code that processes events and a runtime that passes requests and responses between Lambda and the function code. You provide the code, and you can use the provided runtimes or create your own, as I mentioned in the last slide. At the time, you can create a Lambda function when you specify a handler, which is a function in your code that AWS Lambda service can invoke when the service runs your code. The next is the event object. So think of an event as a JSON formatted document that contains data for a function to process. The Lambda runtime converts the event to an object and passes it to your function code. When you invoke a function, you determine the structure and contents of the event. So for example, the content of an API request, the item on an SQS queue, the location of a file on S3, things like that. Finally, there is a context object. So when Lambda runs your function, it passes this context object to the handler. This object provides methods and properties that provide information about the invocation, the function itself, and the underlying execution environment. All right, so we have talked about serverless and Lambda together a lot, but serverless is a lot more than Lambda. Compute services can and have been commoditized. Just look at AC2. AWS led the way with Lambda, but then there are other serverless compute services available today. And while Lambda offers many key advantages for our customers, it's really when all these other components around Lambda that we start to see much bigger benefits. Messaging, orchestration, storage, and compute together are the secret sauce. But in fact, it's really when all these components come together that we really start to see the big gains. So let's talk about few of these services that you see on the slide. I want to start with Amazon EventBridge. With EventBridge, you can build an event-driven architecture that connects application data from your own apps, SaaS, and AWS services. Next, I want to talk about API Gateway, which makes it easy to create, publish, maintain, monitor, and secure APIs at any scale for your serverless workloads and web applications as well. Using step functions, you can coordinate multiple AWS services into serverless workflows, so you can build and update your apps quickly. Next is SQS. With SQS, you can decouple and scale microservices with message queues that send, store, and receive messages at any volume. And by using SNS, which is Simple Notification Service, you get reliable, high throughput pub/sub, SMS, email, and mobile push notifications. Finally, I want to talk about AWS AppSync. The AppSync service helps you to create a flexible API to securely access, manipulate, and combine data from one or more data sources. Now, we talked about how to just write your Lambda code and upload to your console and be done with it. But in reality, that's not really a preferred way. And again, it's not just Lambda function. We're talking about all of the services that we just saw on the last slide. So how do we make the deployment model, the serverless deployment model, really easy on AWS? And this is where AWS Serverless Application Model, aka SAM, helps us. It's an open source framework for building serverless applications. It provides shortened syntax to express functions, APIs, databases, and event source mappings. With just a few lines per resource, you can define the application you want and model it using YAML. During deployment, SAM transforms and expands the SAM syntax into AWS CloudFormation syntax for those of you who have used it, which enables you to build serverless applications really faster. The second component of SAM is the SAM CLI, which provides a Lambda-like execution environment that lets you locally build, test, and debug applications defined by the SAM templates. You can also use the SAM CLI to deploy your applications to AWS. Both SAM and SAM CLI are open sourced under the Apache 2.0 license. Now that you are equipped with AWS Serverless Info, to get started, I would suggest finding your serverless developers and really understand what they're doing. You might think that serverless has not made its way to your organization yet, but in our experience, developers will always find faster ways to complete repetitive tasks, and you'd be surprised how pervasive serverless is. Then think about building a small team dedicated to evaluating serverless. Ideally, this is a cross-functional group representing multiple teams so that all learnings can easily be spread across your organization. Finally, make it the first tasks of this team to choose a lighthouse project, something that can be achieved in a few sprints. will deliver immediate value, but isn't really part of your core application functionality. The idea is to get a reasonably quick win and drive momentum from there. With that, I conclude my session. As always, if you are further interested, feel free to reach out to me directly. I'll be happy to connect and help you with your serverless endeavors.